Looking here at example 5, my initial reaction is to make the angle what my u is going to be. So let's try that out first. So if u is this, I'll write that as maybe t to the 1/2 plus 3. Okay, then du would be 1/2 t to the negative 1/2 dt. Or cleaning that up or writing it a little just slightly different, would be 1/2 square roots of t dt. Alright, so let's go to our main function and see what we've got. I've got the 1 over the square root of t. I would just need to put a 2 there and counterbalance that with the 2 out front. And then I just have cosine of, looks like u. Alright, so let's see, we can write this then as 2 times the integral of 1/2 square roots of t times the cosine of the square root of t plus 3 dt. So actually doing the substitution would be 2 times the integral of cosine of u, and then this 1 over the 2 square roots of t times dt is du. Okay, so what is our integral of du? Remember, change your mode back. What's the integral of, not of du, what's our integral of cosine of u? And since that angle itself is just, this time just has a 1 in front of it, we don't have to worry about doing much. So all it's going to be is sine of u and then plus c. So making that substitution then is going to be 2 times the sine of our, I guess I'll write it as the square root of t plus 3, and then 2 times c will be just a larger c. And there we go. Okay, so here with example 6, we're doing the same process again, just getting more practice with it. And wow, this is going to be a crazy problem because I'm looking inside this radical. My initial reaction is to say, let's make what's in here the u. So if I say the u is the x squared minus 1 over x squared, then when I go to do that whole du, I have the quotient rule I've got to do. You know, the bottom times the derivative of the top minus, and you get the idea, all over the bottom squared. Well, does that look like something I have present in that equation? No, not so much. So let's nix this whole idea and see if we got something else we can do. Well, looking back at, I still like what's underneath that radical. That's still kind of sparking something in my eye. But I want to kind of maybe come over here and let's clean this up a little bit because we can reduce this. We can write this as the integral of 1 over x cubed. And then, so right now I'm not doing anything that has to do with substitution, nothing doing the integral. All I'm doing is cleaning my function up. It's like combining like terms. Well, what's x squared over x squared? 1 minus 1 over x squared and dx. Alright, now let's start with this guy. Looks a little bit better. If I say, let's let u still be that part underneath the radical, so 1 minus 1 over x squared, then let's let, taking the derivative, obviously the derivative of 1 would be 0, and let me just write it like this. So that way we can take the derivative nice and easy. Pull that negative 2 down front, so it becomes a positive 2, and then x to the negative 3 dx. Or we can see du as being 2 over x cubed dx. Now look at what we've got going on in here. So this part right here would be u. I've got the 1 over x cubed. I really just need this to be a 2. So if I put the 2 right there to counterbalance it, then I'm going to put a 1/2 out front. And it looks like we got something a whole lot nicer. So let's go with this thought then. So if I want it now as the integral of 1/2 times the integral of 2 over x cubed, square roots of 1 minus 1 over x squared dx, then we're going to take this and that to make the du, and then all we have is the square root of u. So it's going to be 1/2 the integral of the square root of u du, or 1/2 times u to the 1/2 power du. So now taking the integral, let's add 1 to that exponent. So u to the 3/2 divide by that new exponent, and then plus c. Or it's going to be 1/2 times 2/3, whoops, get a little carried away there, times 2/3 u to the 3/2 plus c. Go through and let's make our substitution back in, and we can call this one done as well. So 1/2 times 2/3, my u, which is, got to go back to figure out which one I did use with. I did that one. So 1 minus 1 over x squared to the 3/2 power, and then plus c. So now let's just kind of clean this up and we're done. A half times 2/3 would be 1/3. 1 minus 1 over x squared to the 3/2, and a larger constant, c. And there's your answer. All right, let's go on to the next two examples. Here in example 7, if we start looking at this a little closely, again, let's just play around with it. Let's try to figure out what can u be. And so if I say let's let u be x minus 4, then du is just 1 dx. I'm like, oh wait, what am I going to do with that x on the top? Well, if you scratch that and say, okay, let's let u be the x on top, then du is still going to be the same thing. It's just going to be dx, and then what do I do with that whole thing in the bottom? Or if I let u be, let's say, x minus 4 cubed, then du is still going to be crazy because it's going to be 3 times x minus 4 squared dx. And that definitely don't have all that in the top. Okay, so I just kind of want to exhaust these so that way y'all kind of agree with me, hey, I've tried that. I'm actually going to go back to our first pairing. That's the one I want to go with. And let me show you why. Okay, because right now I can write that as just, over u cubed in the denominator, and then we have our du on the right. Okay, so I can write this, so I'll put the x right there, but I can write it as u cubed, and then dx is du. Well, do I have something that I can replace x with that's in terms of u? Of course, let's come up here. Let's go to our main u. If I just switch this around, it can say then that u plus 4 is equal to x. And now I can replace an x with something that's in terms of u. So we can look at this as now the integral of u plus 4 over u cubed du. And everything's there. It's all in terms of u. There's no variables outside in the front, so we're good. So now to take the integral, we're just going to break it up as to u over u cubed, or 1 over u squared, plus 4 over u cubed, all of that du. And then just writing it one more time to where we can actually kind of more analyze the exponents. It'll be the integral of u to the negative 2 plus 4u to the negative 3 du. Okay, so the integral of u to the negative 2 would be u to the negative 1 over negative 1 plus 4, and then u to the negative 2 over negative 2 plus c. Well, let's clean that up. So negative u to the negative 1 minus 2u to the negative 2 plus c. And last but not least, let's plug in what we have. U is x minus 4. So x minus 4 to the negative 1 minus 2 times x minus 4 to the negative 2 and plus c. And the answer in the back of the book might have written it with positive exponents, so just in case, if we want to go in there and just have that practice in there, then it would be negative 1 over x minus 4 minus 2 over x minus 4 squared and plus c. And so that would be the equivalent answer, just with positive exponents. All right, let's wrap this lesson up and go on to example number 8. Here in example 8, we want to solve this. So that's why they're going to give us kind of some boundary points here. Is because instead of having everything now in terms of plus c, they've given us some information. So now we can actually determine what c is. But we're going to start the same process, or this process, with how we've been doing the problems prior to this. I have a function, and I want to be able to, obviously they've given us information that has to do with the function as is. We have the derivative over here, but I need to go back to the main function in order to use those values. So in order to go back to the main function from the derivative, I need to take the integral. So let's take the integral of 4x times x squared plus 8 to the negative 1/3 power. All right. Well, again, this looks like something that's going to be a little bit tricky, so we're going to go in there and try to do some of our substitutions. Usually anything that has a power to it, I start with that as trying to be my u. So u is equal to x squared plus 8, then du would be 2x dx. Okay. Well, I've got 4x. I only need half of that. So how do I do that? Let's come in here. Let's play around with this. So if I take 1/2 of the 4x and x squared plus 8, by the way, I forgot, you put a little dx in there. Move that guy over so we can do this. Okay, so if I make that my function, in other words, so I multiply 1/2, so I counterbalance it with a 2 out front, then you make that a prettier 2. Okay, then cleaning this up, or rewriting it just one more time, then it's the integral of 1/2 of 4 is 2x times x squared plus 8, so the negative 1/3 dx. And look here, we've got everything in place now. Here's my u to a power. My 2x dx is my du, so we're ready to go. So this is 2 times the integral of u to the negative 1/3 du. So coming now, taking the integral, it'd be u, we're going to add 1 to that, so it'd be 2/3 divided by that new exponent plus c, or 2 times 2/3 u. Sorry, I already flipped it on accident. Just a second, let me go back and fix that. I'm used to writing 3/2, so I need to write that as 2/3. Same exponent needs to be down there in the bottom. So now flipped is 3/2 u to the 2/3 plus c. Okay, let's distribute this inside of here. So this will be 3u to the 2/3 plus c, and now we can plug our u in. Our u being x squared plus 8. So 3 times x squared plus 8 plus c. And so what we have found is our function for y. So we took the derivative, or we took the integral of dy, and we get y. So now let's go in and actually find what c can be using our points. It says y equals 0 when I plug in x. So 0 is equal to 3 times 0 squared plus 8 plus c. So 0 is equal to 3 times 8 plus c. 0 is equal to 24 plus c, or c is negative 24. So coming in here, taking that away and putting in a negative 24, and we've got ourselves our answer. So y is equal to 3 times x squared plus 8 minus 24. And there is our final answer for the function of y that has a derivative of 4x times x squared plus 8 to the 1/3, and it goes through the point 0, 0. All right, guys, let's go on to our last and final lesson for this class.